Good morning, everybody. Welcome to our webinar on tips for manipulating data in Esri Geodatabase using FME. I'm Mark Stokes, and with me is Mita Hajiraka.
Hi there.
And also with us, we've got, so we're from Safe Software here in Vancouver. We've got 95 plus employees here, all based in Vancouver. And that's where we're transmitting our webinar from today. And FME Technology, for those of you that haven't become familiar with our products yet, is used to translate and transform data from a wide variety of spatial and non-spatial data formats. Our product originated in the CAD and GIS area, and we expanded that to work with spatial databases. And then over time, we've been adding different spatial data types to FME: Raster, 3D, XML, and web-based formats, and more recently, point cloud. And so within that arena, what we've been also adding is a wide range of transformation tools to help move the data between the different spatial contexts of the data formats that we support. So just to start off the presentation, we'd just like to ask a couple of questions about how you're using FME. So we have a couple of polls here to wake everybody up and get everybody moving. So the first poll is, how long have you been using FME? And so we're going to launch that poll there. And so we'll give you a few seconds to answer those questions. So we've got a wide variety this time round. About 20% people have not seen FME before. Quite a few newcomers, about a quarter of the attendees. We've got about 220 people listening in today. So about a quarter have been using FME less than a year. And so I'm just going to close that poll and then share the results with everybody. So those are the results. So about a quarter new, relatively new users to FME, and about half of us are very familiar with FME. So that's a wide spread today, actually. Often our webinars lean very strongly one way or the other. Okay, and I think we have a second question we're going to ask now. Is that right, Nita?
That's correct.
Are you currently using FME Desktop, and if so, which version? So again, I'll give you a few seconds to answer those questions. Wow. A lot of people on the bleeding edge here. Okay, I'm going to close that poll now. Oops, there's still people answering away here. So, okay, that looks like that. So I'm going to close that, and then I'll share that with everybody. So half of us on the bleeding edge and have downloaded our latest version, FME 2012, which came out in January this year. And I think we have just, within the last couple of weeks, released Service Pack 3. Is that correct?
That's correct.
Yep.
Last month.
So encourage those of you that are on 2012 and can upgrade to keep moving forward. And for those of you on older versions, we'd really encourage you to upgrade to the newer releases. Sometimes we know that's sometimes very difficult for you. And within there, we do have some people who are using FME through the Esri data interoperability extension. So that's interesting. So for those of you that don't know, FME technology is embedded in Esri as the Esri data interoperability extension. Okay.
Okay, so good morning, everybody. Thanks, Mark. My name's Mita, and just on the lines of the Esri data interoperability, I do want to mention before I start into my demos today that all of these demos can be done inside of the spatial ETL tool in Esri's data interoperability. So if you do just have that product, you know, this is a worthwhile webinar for you to see. So this is my agenda for today. It was kind of difficult picking the topics for today's webinar because there's so much functionality in a geodatabase. But we kind of went ahead and decided to go with topics that we hear about through support. So I'll be talking about annotation, domains and subtypes, attachments, metadata, and rasters today. We are recording this webinar and we'll send you links to the webinar as well as links to all the materials that you see today after we're done. Questions are encouraged, so we have Robin Rennie and Laura Kersons from the Pro Services team here as well, and they will answer any questions you throw at them. To submit a question, just take a look at your GoToWebinar panel at the bottom there and you'll see the section for submitting a question. And if we don't get to your question during the webinar, we will send you a follow-up email. There are many geodatabase formats you can work with in FME. All of them require that you have ArcGIS installed and licensed, except for the File Geodatabase API format. Now that is based on Esri's Open API. If you do use that one, there's a bit of a word of warning there. There is less functionality with that format compared to the ArcObjects-based formats. The one I'll be working with mostly today is the File Geodatabase ArcObjects format. For the raster demo at the end, I'll be working with the ArcSDE Geodatabase raster dataset. So what do I have here on my laptop? I have FME 2012 SP3 installed. That is the official version that's compatible with ArcGIS 10.1. Of course, I have that installed as well. And again, for the raster demo, I'll be writing to an ArcSDE 10.1 database. In order to run my demos today, I do need the FME Esri Edition license or higher. Okay, just a couple more poll questions before I move into the demo. So Mark, can you bring up a couple more of those poll questions?
Okay, so the first question is what version of ArcGIS are you using? See which of the Esri folks have been keeping up to date with the Esri products. Okay, a couple more seconds and I'll close that poll. And so majority of people still on ArcGIS 10 and quite a few people have moved already to 10.1. Actually, that's quite impressive considering how much work it is sometimes to upgrade a big system. So, so that's good. And we've got just another follow-up question for you. On that is, well, we know the answer to this one. So when are you planning to upgrade to 10.1? I have already, so we'll have quite a few people there. Okay, and just a couple of minutes there, a couple of seconds, I mean, for closing that poll. Here we go, and so those the results there. So a few people are planning to upgrade almost right away, so that's kind of interesting. Okay.
Okay, so before I launch into my demos, I just want to show you guys what kind of data I'm going to be working with. I'm going to be working with some navigation data, so it's data, electronic navigation chart data, and it's in S57 format. I'm going to show you what it looks like here in my Windows Explorer first. So notice I have a number of folders here. These all represent tiles of ENC data. All the data is from the San Francisco Bay Area. And I do have one of the tiles loaded in the Universal Viewer as well. So you see there's a lot of different layers within this particular tile. This is the 12M tile. I've only turned on the layers that I'm going to be working with during the demo. So we've got most of these dark red points here are the soundings features. We've got some buoy features as well, 3 layers of buoy features, and also the lake areas. Okay, so those of you working with Geodatabase, or most of you working with Geodatabase, will probably have to work with annotation features. moving annotation from one geodatabase to another is pretty straightforward, but as soon as you get involved with other formats, working with annotation does become more complex. Some formats don't even support annotation, and that's the case that we've got here today. S57 does not support annotation. So we're going to be loading the sounding points to a sounding feature class, a point feature class, and we're also going to be creating some annotation from our points and loading that to an annotation feature class. Now I already have a geodatabase model in place. I'll show you that right now here in our catalog. I have a file geodatabase here, feature dataset called ENC, and within that a number of point, line, and polygon feature classes. So what we're going to load is the sounding features here and the sounding feature anno. And I just want to take a quick look at the properties of the sounding feature anno. And if we look at the annotation classes here, I have set up two annotation classes within here, annotation class 1 and class 2. And then if we look in the annotation tab, I also have a standalone symbol in my symbol collection. So that's what we're going to be working with when we load. So let's create a workspace, an FME workspace from scratch here. And I'm going to start with a blank workspace, and what I'm going to do is add my reader and writer separately. So from the readers menu, we'll add a reader, select the S57 format, and I'm going to load data from one of the tiles in my S57 data set. So we'll load data from that 12M tile. So it's .000 is the extension for S57 files. Now Workbench is scanning and presenting me with the layers in that particular file. I'm only interested in the soundings, so we'll check that on. And the reader side is now taken care of. We'll now go to the writers menu and add the geodatabase writer, the file geodatabase arc objects writer. And we'll pick that file geodatabase that I just showed you guys in our catalog. So that's it there. We'll just hit OK. And Workbench has now asked me if I want to add a new feature type. We don't want this because our table already exists in our geodatabase, so we want to import it onto our canvas. So from the writers menu, I'm going to import those two tables, the sounding feature and the sounding feature anno. So I'm just going to put a filter in here so I can get to these pretty quickly and select them both. And there's not much transformation we're going to do with the points. Let's just double check which one of these is the actual point. So it's that bottom one, the sounding feature. So I'm just going to move that up here. We'll move the annotation down to the bottom here. And I'm just going to connect up the points straight to the point feature class. The transformation we want to do is with the is to create some annotation. Now, taking another look at these sounding features in the viewer, I'm going to select one of these points, and I actually want to create the annotation from the depth values here on the point features. But if we look at the actual attributes here, there is no depth field. The depth is actually held in the geometry, so notice there is a Z coordinate on these point features. So that's what we're going to use for our annotation features. So the first thing we need to do is actually extract those coordinates and make them attributes on our point features. And we have a handy transformer called the coordinate extractor that will allow us to do that. So we'll join that up and go into the properties of the coordinate extractor. I'm just going to stick with the defaults here. So we're going to have three new attributes, _x, y, and _z on our features after the coordinate extractor. The next thing I want to do is actually create my annotation or my labels. The label point replacer does exactly what its name says. It replaces the points with actual labels. If we go into the properties there's two things I need to set. One is the label attribute, and that's coming from my Z value. And then the label height. Now my data is actually in decimal degrees here, so not the easiest units to work with, but this 0.00004 will give us a decent sized annotation. And this is in ground units, of course. Okay, now if I just connected that up now, this workspace would run and it would load annotation using the default annotation class. but you saw that I have a couple of annotation classes and I have a standalone symbol. So what if I wanted to actually change the annotation class I wanted this data to be written with? Now, you guys all know that there's some standard fields on an annotation feature class. You can see them here on the schema. You never work with these attributes directly. You can't do so in ArcGIS, and you can't do so in FME either. What you do instead is work with what are called FME format attributes. And to find out where the format attributes are, you'd go to the destination feature type here, the properties of it, and there's a Format Attributes tab. If you scroll down, you'll start seeing a number of GeoDB underscore format attributes. And if you don't know what a format attribute is, all they are is they're FME generated attributes, and they hold additional information about the symbology or the structure of your features. So we're interested in this GeoDB Anno class ID to start. So how do you know which GeoDB Anno class ID actually goes with the second annotation class that we have in our feature class? So let's just go back to our catalog one more time and look at the properties of that sounding feature Anno. A couple of places to grab the number you want to use for that GeoDB Anno class ID. You can either look at the symbol collection here and grab the number there. So I want 1 for annotation class 2. Or under the subtypes, the annotation class ID subtype field has a code of 1 for annotation class 2. So I'm going to load my data with that particular class ID. So what I'm going to do is throw an attribute creator down on my canvas, and we'll set up that GeoDB Anno class ID. Give it a value of 1. Okay, so if I run this, it will load with that particular annotation class. Now there are other format attributes, or actually lots of geodatabase format attributes you can work with. So going back to my Format Attributes tab, notice all of the GeoDB font format attributes available to you. The other thing I'm going to do is change up the font name. Currently, that annotation class is a Times New Roman font. So it's perfectly valid for me to actually go in and modify the font for this annotation class by simply setting that particular format attribute, and we'll change it up to an Arial font. Okay, so I'm going to run this workspace now and go ahead and load both of these few classes. All right, so now let's go back to our catalog here and just do a quick refresh. Okay, I'll have to zoom in a little bit here. And what we should see are some annotation features with the Arial font. And remember, second annotation class was in red, so I'm pretty confident here that we loaded with the correct, with what we expected. Okay, and symbol IDs work very similarly to annotation class IDs. So again, you'd grab the symbol number from the symbol collection. So this happens to be 2. And in order to load with a particular symbol, back in the attribute creator, I would just delete these 2 here, and I would set up the GeoDB symbol ID. And that would be 2. And if I ran this workspace again, of course, I'd want to do a truncate and load. So in order to truncate a table, you'd need to go into the destination feature type properties, format parameters, and you can truncate your table there if you need to reload it. I won't run that again, just wanting to show you guys how to work with a particular symbol from the symbol collection is with that particular format attribute. Okay, so I just want to review what I did. The key thing to know when working with annotation is to never try to write directly to those annotation fields you see on the schema. Always use the GeoDB format attributes. If you want to reference the GeoDB Anno class ID, you can go into our catalog and use the subtype code or code from the symbol collection, and you reference the GeoDB symbol ID using the symbol ID found in the symbol collection. So that was just a small taste of what you can do with annotation inside of FME. FME does also support many other annotation features. These include things like simple leader lines, multi-part annotation, and feature-linked annotation. Feature-linked annotation is quite common, and it's very easy to work with inside of FME. The key there is you need to make sure you've set up your feature-linked annotation classes inside of your geodatabase first. And then with FME, you simply write to the main feature class or the spatial feature class, and then the geodatabase handles populating the annotation and the relationship classes. Okay, so that's annotation. I'm going to move on now, and we'll talk about domains and subtypes. This time we're going to work with some buoy features from our ENC data. So let's take a look at what the buoy features look like inside of our viewer here. I'm going to turn off the soundings now. And we've got, again, some point features here. So this boy lat, boy saw, and boy SPP represent different kinds of buoy features. Now, in our catalog, we have one buoy feature class that we want to write to. Okay, so we're going to be reading from multiple layers on the source and writing to one on the destination. If we take a look at the properties of this buoy layer, notice under subtypes, the buoy type is a subtype field, and it's got 6 different codes for buoy type there. And I just want to make a note of one of the attributes in our S57 data. Notice that there is this, if I select one of these features, there is this boy SHP field. It's an integer value, but it represents essentially the buoy type, and it maps directly, that code maps directly to the subtype code, so that 4 is a buoy lateral inside of our database. So that's what we're working with this time, and we'll again create a brand new workspace here and start from scratch. Now, in the annotation workspace, I was only reading from one of the tiles in our data set. This time I'm going to set the workspace up to read from all of the tiles within that S57 data set. So we'll add the S57 reader again. And this time, instead of selecting the Open File Browser, I'm going to select the Open Advanced Browser. This will allow me to add a directory and to scan that entire directory for data. So we're going to pick our ENC root as our folder. And I know all my files are .000, so I'm going to delete the second one here. And we're going to ask the reader to scan all subdirectories. So again, Workbench is now scanning all of those files for the layers within them. And I presented a list of what I put on my canvas. Okay, so just the buoy feature types this time. Okay, so now on the reader side, let's add our geodatabase writer. And again, we're going to select that same geodatabase we've been working with. And again, we're going to import our buoy feature onto our canvas. And from the writer's import feature types, I'm going to now hit the parameters button here, and I'm going to select the buoy feature from my table list. Now notice there are 2 parameters here around domains and subtypes, resolving domains and resolving subtypes. I'm going to make sure they're both checked on, and we'll come back to what that means in just a second. Right now, what I'm going to do, what we know is that we need to map the names of these feature types, boy saw, boy SPP, and boy lat, to the actual subtype codes. So the first thing we need to do is get those feature type names in an actual attribute. So our feature type extractor will do that for us. We'll connect those up. And if we take a quick look at the parameters here, underscore feature underscore type is the name of the attribute that will be put on all of our features. The attribute value mapper is really handy for this situation because it will allow us to map source attribute values to destination ones. So if we go into the properties of this, our source attribute is the feature type that we just created. Our new attribute, or the attribute we want to write to, is the buoy type. And then we simply need to map our feature type names to our subtype code. So boy saw maps to 5, boy SPP mapped to 6, and our boy lat maps to 4. Okay, I'm going to connect that up and go ahead and run that workspace. While that workspace is running, I wanted to talk about what happens when you resolve subtypes and domains on in the parameters of that destination in that destination handler. We expand all of these attributes here. Notice way at the bottom, what we have is a attribute automatically closed, and it's called geodb underscore subtype underscore name. Work with that as well. So if you want a description rather than the code, you would work with that geodb subtype name. So in the attribute value mapper, I would change this new attribute to geodb subtype name, and then map to the description. So this one, for example, would be buoy, safe water, etc., etc. Okay, so we won't run that. I just want to see the results of my first run of the workspace. So we'll refresh the buoy feature here. And you probably can't see the coloring on here, but they are colored by subtype code. Let's just take a quick look at the table. And if we look at the buoy type, we see we have values for our buoy type here. So that's an example of writing to existing subtype. Domains work in very much the same way. So when you, so I can write, let me just take a look at the user schema here. So boy shape is one of our coded domains in that database. So notice when I resolve domains, I also get, Workbench creates this boy shape underscore resolved attribute. So if you have codes, you can write directly to boy shape, and if you have descriptions, you can write to boy shape resolved, and that behaves in the same way that subtypes do.
So those descriptions would have to exactly match the descriptions that are in the domain.
Exactly, yeah. And Workbench will automatically validate if you end up writing incorrect codes or descriptions. It will throw an error. Domains, however, are not validated automatically. If you want to turn on domain validation, you would need to go to your geodatabase writer in the navigator pane here, expand the parameters, expand the advanced parameters, and notice there is this validate features to write parameter. By default, it's no. If you want to validate domains in the same way subtypes are validated, switch it over to yes.
And the way that you've got it configured here, if we wrote to a brand new geodatabase that didn't exist, it would create all those domain tables for us.
Yes, if it's set up exactly the way it is here, exactly. If you wanted to create your own domain, you could actually do that. So from the User Attributes tab, say I wanted to create a new attribute here. Look at the types here. I can actually create my own coded domain or range domain for that matter, attribute, or my own subtype or subtype code. And I'd have to go into the edit screen, enter my domain name, click create domain, and then enter my codes and descriptions. Now, that's generally not what we recommend. I mean, we recommend that you set it all up with our ArcGIS tools beforehand. If you don't have a geodatabase model already in place, perhaps you have an XML workspace document. So you could reference, again, in the writer's parameters here, there's a template file. So if you have an XML workspace document of a schema that you want, reference it with a template file. What FME will do is we'll create that entire model for you first, so it includes domains and subtypes, and then it will load the data for you that's represented on the canvas. Okay, so let's move on then. So to review what we did, you can write to both the code or the description of the subtype and domain. An attribute value mapper could be a very useful transformer in these situations. As I said, subtypes are validated by default, and domains are only validated if that validate features to write is set to yes. You can create subtypes or domains and write to existing ones with FME, but one thing to keep in mind is you can't modify existing subtypes or domains. So there we go with the domains and subtypes. Next demo. So we're just going demo after demo today. I'm going to move on to attachments now. Attachments are a pretty new feature of the geodatabase. I believe they were introduced with ArcGIS 10. And often, what they're used for is to attach files to features in your database. Often these are things like images, such as JPEG files, or things like PDFs, which reference documents. What we're going to do is load some photographs into an attachments table and set up the relationship class entries with associated lake features. So I've already got a workspace set up for this one here. Before we take a look at it, let's take a look at the data that we're working with. So I have a number of JPEG images, and these are here in my photos folder. Okay, so these ones here, about 6 of them. And I'm going to be working with the lake area feature class in my geodatabase. So that's this polygon feature class here. And then my source data, if we look at that in the viewer, I'll just select this lake here. And notice that there is this OBJ name. This one is Bolinas Lagoon. Notice I have a Bolinas Lagoon.jpg. So you can kind of see how we're going to be joining the pictures to the spatial features themselves. We're going to be using the name of the lake. Okay, so this workspace is a little more complex than what we've been showing you so far. And I'll just step through the main portions of this workspace. So at the top here, we're just reading our lake area feature. At the bottom here, we're using our directory and path, or directory and file reader to read the photos in. I actually want to show you what that reader does. So I'm going to use that reader in the FME viewer here and read those JPEG files. I'd like you guys to see what kind of attribution ends up on your features. So it's the directory and file path names reader. And what you need to do is select the folder that contains the photos. And of course, there's no spatial data here, so I have to use my Select Node Geometry button to look at the attribution here. If we go to the right, I've got my 6 features here, 1 of 6, and I'm just going to navigate over to our Bolinas Lagoon picture. So take a look at the kind of information we have here. We have a full Windows path, we have a path root name, so that will exactly match that OBJ name that's in the spatial data. We've got things like extension, etc. So there's some useful information in there. So that's how we're reading the photos in at the bottom here. So let's focus on this top bookmark now. The trick to working with attachments is to set up, again, format attributes, this time relationship format attributes. So what's happening up here is we're telling the writer that this feature has relationships by setting the GeoDB feature has relationships to yes. I then need to add a unique ID in the form of the GeoDB OID format attribute. This is the equivalent of object ID. And then that top stream there, I'm just writing straight to the lake area feature class. In this bottom stream here, I'm just taking a copy of all those features, and the attribute renamer is copying that GeoDB OID to a GeoDB rel origin OID. The origin is in the name there because the lake areas are the origin table in my relationship class. I should probably show you guys that in Art Catalog first. So I created these beforehand. So for lake areas, we created the attachments, and these are the 2 tables that were created. There's our relationship class. Properties will tell us lake area is the origin table, and my lake area feature underscore attach is the destination table. Okay, so that's the top part of the workspace there. We're doing the exact same thing with our JPEG images here. This time in the attribute renamer, we're mapping to GeoDB rel destination OID. And then the bottom part of the workspace here is we're simply setting up fields for the underscore attach table. Basically, this attribute copier is copying some of those source attributes that we just saw in the viewer to target attributes. Of course, the key is really that rel object ID. Another key attribute here is the attribute file reader. So this is essentially taking that path windows attribute, so the full path to the JPEG, reading that file, and it's putting it as a blob into our data field on our destination table. And then that all gets written to that _attached table. The bottom of the workspace, the middle of the workspace is basically where we set up the relationship, and the feature merger is key for that. Again, we're connecting the lakes to the images using the OBJ name from the spatial features and the path route name from the pictures. Then we just set up this another format attribute called GeoDB type, set it to GeoDB relationship, and write that all of that to our relationship table. So that's essentially it. I'm going to run this now, and while this is running, what I will say is you guys are all going to get all of these workspaces after the webinar. If you do need to work with relationship classes or attachments, what I recommend is not to start from scratch. Take this workspace and modify it with your data, and simply go into the various transformers and adjust them to your need. It's easier than starting from scratch. Okay, so let's go in and take a look at what we have here in our attachments table. So there we go. We've got our 6 features there. Easier to take a look at this in ArcMap. So I'm going to drag over the lake area features onto the canvas there and take a look at one of the attachments for that big lake. So if I identify this guy here, notice I have the attachments available to me now, and I can go ahead and bring up the attachment for that particular lake.
And of course, those attachments don't have to be images, do they, Mita? They
No.
can be any document or anything
Exactly.
that can be stored in a blob in the
Exactly.
database.
Yeah. Typically, I think PDFs are probably one of the more common formats for document type attachments. Okay.
And just to reiterate what Mita said a little earlier, that there are a lot of format attributes in there. It's kind of a little bit confusing sometimes, but the pattern is very repeatable, so pretty well any attachment works in the same way. And so grab that example when it gets published onto the website with this webinar, and then you'll be able to quite easily create your own attachment configurations.
Mm-hmm. All right. So just to review what we did, attachments must be built with ArcGIS tools. You cannot create them with FME. But again, if you do have an XML workspace document, use that template file parameter instead on the Geodatabase writer and let FME create the model for you before it loads the data. This is a list of the format attributes that are available that need to be set when writing to attachments.
And so we do have somebody here. Do we know the answer to this question that somebody's asked us? How many attachments can be linked to a feature class? Do we know whether we can link more than one attachment to a particular record? We don't know the answer.
We don't know the answer to that. Let's take a look at, let's just take a quick look in our catalog and see if it's a one-to-many relationship class. I think that will, it is a one-to-many relationship class. So I'm guessing that yes, you can have more than one attachment per feature. That's a good question. Okay. Let's move on now. We've got a couple of more demos to do. The next one deals with metadata. So in this example, I am updating existing metadata. And again, I already have a workspace set up that I will review with you guys. The metadata I'll be working with is from the geodatabase we've been loading, so the sounding features. Let's take a look at kind of metadata we have on the sounding feature itself. Not very much. So very minimal. We've got a title here, we've got some tags, and we've got some summary information. All I'm going to do is update that summary field. So it's actually a very simple metadata example. I'm going to point you guys to some other resources so that you can get more up to speed with working with metadata and XML. But for now, I'm going to show you guys what I've done here. So what we've done is read that sounding feature in using the File Geodatabase ArcObjects reader. The key to reading metadata in with FME is to make sure a parameter on the reader, so I'm going to expand my reader here and go to the advanced parameters. You need to set the feature read mode to metadata. So by default, you've got two options, metadata and features. By default, it's features. You need to switch it over to metadata. And when you do that and run the workspace, what happens is that FME will populate a format attribute called GeoDB metadata string. And all I'm simply doing is exposing that format attribute with my attribute exposer here. This is XML inside the GeoDB metadata string. So at this point forward, you got to work with XML. The XML updater is basically what's used to update that summary information in my metadata. So let's take a look at the XML updater. Okay, so my XML document, so basically I'm saying my XML input is coming from a text or an attribute. The XML text I'm working with is that GeoDB metadata string. We have various options for update type here. We're going to be replacing contents. And then we need to make sure we get our XML path right. So my path is metadata / data ID info / ID PURP. Now, how did I figure out what that was? I used another transformer in FME to figure that out. So I'm just going to cancel out of here for now. And I'm going to disable the bottom part of this translation and enable this XML formatter. So this XML formatter logger combination allows me to see XML in the log file in XML readable format. So if I just pump that GeoDB metadata string into that XML formatter, which I should probably take a look at the properties of that thing. All I did was say XML input, attribute specifying XML text, and then I chose my GeoDB metadata string. I didn't do anything else inside of this transformer. We run that workspace and keep an eye on the log file. We'll see what that XML looks like. We'll see the hierarchy of the XML very nicely. Okay, so there it goes. It just flew by. I'm going to scroll up a little bit here. And here we have it in XML readable format. So I essentially picked the path to this ID PURP, so that's our summary information there. I picked that out from the log file and I updated the XML updater with that information. So that's just a little tip for working with XML. I'm just going to disable that portion now and enable our XML updater again. So back in the XML updater, again, this is just a very simple demo. So I'm just providing some plain text as my update value. So I'm just going to say soundings or San Francisco Bay Area soundings carry depth information. Okay, so that's what we want as our new summary information. I'll hit OK there. The creator here, some of you are probably wondering what that's doing. It's not really doing much. All it's doing is providing an input to the update port. Currently, it is required that something go into that port, so it's just a null feature, not really playing much of a role at all. All right, so let's go ahead and run this workspace now.
Don should be at this demo meter because
Yeah,
he's the
he'd
guy
love
that
it.
loves XML, and it is human readable, so we can see what's going on.
Yeah, I wouldn't be able to finish the rest of my demos if Don was here.
That's right.
I think we just do XML the rest of the way. All right, so let's take a look at the sounding feature summary again, and there you go. You see I was able to update my summary information with what I put in that XML updater. Okay, so a quick review of metadata. When reading metadata, you need to make sure you've switched that feature read mode on the Geodatabase reader to metadata. When you do that, the GeoDB metadata string format attribute holds the XML metadata. So there's a lot you can do with XML inside of FME. And like I said, I kept that demo very simple because we have 3 pre-recorded webinars. If you follow this link here, that'll really help you work with XML and metadata. One is all about reading XML. There's another one all about writing XML. And there's an entire webinar on working with metadata inside of FME. So please take a look at the webinars in that link. The recorded webinar section is where you need to go. All right, so the last demo of the day is a raster demo. In this demo, we're going to take a set of tiled raster files, we'll mosaic them, and we're going to write them to an ArcSDE Geodatabase raster data set.
So I think this is probably the only piece of the demo that couldn't be done in the interoperability extension. Is that right?
Yeah, that's correct. That's a good point, Mark. So raster formats are not available in data interoperability. I think it's probably the only kind of data that's not available.
Functionality in FME that's not included in the interoperability extension.
Yeah. Okay, so what are we doing here? We're mosaicing a number of tiles. Let's take a look at, I'm going to show you just in Windows Explorer here what data I'm going to be working with. We're moving away from the navigation data now because we didn't have any rasters in there. I'm going to be working with some rasters in this particular folder here. So these are all tiles of raster data. My workspace is actually just reading the first 4 tiles there. Okay, so we've seen how to do that with the reader, how to read from multiple files at once. So I've got 4 of them there being read by this particular feature type here. I've got my Geodatabase SDE raster dataset writer in here. The one thing I'll point out is that I'm using Direct Connect. By default, with ArcSDE 10.1, Direct Connect is the default way now to connect to databases. So if you do have existing workspaces where you've set up a 3-tier connection and suddenly you can't connect, it's probably because your administrator is upgraded to SDE 10.1 and suddenly you've got to make a direct connection. Now, there is a way to add that ArcSDE service so you can still work with a 3-tier connection, but the thing to do is just check with your ArcSDE administrator on that one. Okay, and the feature type properties here when we're writing to SDE here, I just wanted to point out the format parameters here. So you can set the compression type for this raster. You can set the quality of the compression. You can set the resample type. These are all, you see all of these in ARC catalog as well, and also the pyramid level as well. I'm just going to go with all of the defaults. Let's just change the name of this to, I'll just call it Raster Demo instead. This table. And we can just go ahead and run this workspace. Now this takes a little bit longer to run. So while this is running, I don't know, maybe we can do a little bit of the Q&A here. Do we have any interesting questions that have come in from the audience, Robin?
Yeah, I think one of the questions around the raster would be what would be the resolution of the mosaic and what went into the destination mosaic that we're writing to SDE here. And I think that is the first one in wins, basically. So the first image that comes into the mosaic sets the resolution for that mosaic, and then that is the raster resolution that ends up in your SDE. So all following images would be matched and resampled to that first image in that set the
and is there a way to control the order of rasters that go into the raster mosaic then?
Yeah, you'd have to use a sorter or something like that. You'd have to pick out, like if you wanted to have the highest resolution or the lowest resolution, you'd have to pick out some of the format attributes and sort by resolution and have the rasters ordered in that way or something like that.
Okay. Okay. You got any interesting questions there, Robin? Anything else coming in from the audience?
Updating metadata, something like from Excel or something else?
So updating metadata from an Excel table or something like that. Yeah, we could probably do that. I don't think we've experimented with that. Going into the geodatabase or we could be reading an Excel, provided you can join that Excel record to the feature class that you want to update, then you would be able to,
And
to do that.
I will point out on the XML updater here, you know, I just put in I just manually entered a text value, but you can actually set this to an attribute value. So if you've got data coming in from your Excel spreadsheet, you know, you can probably work with an attribute value instead with the XML updater.
Yeah, so really all you'd have to do there is merge the record from the Excel spreadsheet to, in this case, the sounding feature, and it would update, and then use that attribute to do the update or something like that. And I guess not all the records are updatable, because some metadata in Geodatabase is created automatically, isn't it?
Yes.
Like the spatial domain kind of things.
Yes.
Those are all
right.
Set by the Geodatabase. So you could, even if you update those fields, they'll be overwritten by the Geodatabase as the data gets loaded.
Yeah. Okay, well, our workspace is still running, but I did preload this data beforehand if you don't want to wait for this thing. So why don't we just do that, and then we can finish off the final few slides there. So I thought it would have been finished by now, but it hasn't. Okay, so I did load it earlier into this SDE JPEG 2000 feature class there, and we'll just go with, oh, now it just finished. All right, let's just take a look at my new data that I just wrote. Let's do a quick refresh here on our SDE, and this is the raster demo that we just wrote, and just take a few seconds here for this raster to display. So remember, I had 4 tiles of data, so basically that's the top of a much bigger image, the top 4 tiles of a much bigger image that we just loaded. Okay?
Yeah, great.
Excellent. So that brings us to the end of our demos. We have a few slides. Oh, maybe I should do this last slide, actually, the raster view slides. There are a lot of things you can do with rasters in FME. If you look at the raster category in the transformer gallery there's lots and lots of raster transformers. We have an excellent FME PD at raster landing page as well. Whoops, that didn't work so well. Serves me right from trying to click on a link in my slide. So let's just get back to where we were. And again, you're going to get all these slides, so don't worry about not noting down these URLs right now, but that URL will get you to our FME PD at Raster landing page, which has tons of great examples of things you can do with rasters inside of FME. Okay, so now.
So win a free training session. So if you'd like to enter the competition for a free training session, just answer in there and see whether you'd like to join up. We have fairly soon, actually in early September, a FME for Esri training session coming up. Robin will be running that one. And so if you want to do a bit more hands-on of some of the content in this that we've been talking about here and more, sign up for that one if you get the free training off seat that up for grabs here. Okay, I'll give you another couple of seconds and then we're going to close that poll, so better get your vote in quickly. Okay, so we'll be sharing in a follow-up email, be giving out those seats that draw on that free training offer. So the winners will have until the end of the month to register for that course. So in the follow-up email, you'll be getting the note whether you were a winner in that training offer. Okay, so that pretty well wraps up our session for the day. If you want to follow up with if you're new to FME and you want a bit more of a personalized web demo, contact our sales team at sales@safe.com, and one of us will help them with the demo that might be more specific to your needs. You can try FME Desktop if you want to, download an evaluation copy from our website. We've got a raft of other Esri-related webinars coming up. What's new in ArcGIS 10.1 data interop extension, preparing LiDAR data for ArcGIS 10.1, and easily loading data into ArcGIS for local governments is coming up. So keep an eye on the webinar schedule there. And also have a look at our training calendar. If there's any training sessions that are of interest, you can register for those as well. Whoops. Well, I think that just about wraps up the webinar for today. Thank you very much for attending. Well, actually, it wraps it up in more ways than one, because I think this is Mita's last webinar for Safe Software. Is that correct?
That is correct.
Yes, so it's with great regret that I have to say that Mita is leaving us at the end of August to get married and move on to perhaps more exciting things than Safe Software. I think it's nearly 8 years or 8 years plus that you've been working with us, so yeah. It's been an honor for us all working with you, and we're really going to miss you down the road. Going to be somebody that's very, very hard to replace at Safe Software. Anyway, if there's any, as Mita said earlier on, the webinar has been recorded. We'll be sending you a follow-up email with the link to the webinar recording and all the demos that Mita put together here. And there were a few questions about what is S57, so the demo, those examples will also show you what S57 electronic nautical charting is all about for the San Francisco Bay Area. So thank you very much, Mita, for sharing your knowledge, and we'll be working with you for the next couple of weeks, but I'm sure there's a lot of people out there that who will also miss you at Safe Software.
Well, it works both ways. I'll definitely miss Safe and all the people that I've been working with over the years as well. So thanks a lot, Mark.
Okay.
Thanks, everyone.